Hey, it's Sam here, and I'm here to talk about our GUI. So for our GUI, we have a simple load button that pops up the documents library where you should already have the dog image saved. So I'm just going to double click right here, and then we can choose our hidden image from our pop-up menu, and then from there we get to choose our embedding method, and we choose our recovery method. We need to make sure our embedded method is the same as our recovery method, otherwise we get this not so very pretty stuff. So we need to make sure our embedding is the same as our recovery. So right now this image right here has our hidden image 5 in it. So I want to bring this image back, and the way I'm going to do this is just by clicking this button. Now the image that was here is gone back here. I'm going to choose a different image now. Let's say I'm going to choose image 1. I'm going to load that with blue. Alright, and I'm going to show it with blue. Now we have this image that contains both red and blue. Alright, now we are going to go back again, and I'm going to load image 2, load embedded pic. So the one that has 2 embedded pictures now has gone back here, gone back, and there it is again. Alright, let's say I want to do it again. So let's choose 3 this time. Load the embedded picture, so now that one has 3 embedded pictures in it. Let's go to visible by red. Boom, there it is. So now that is different. And now this image has 4 embedded images in it. So let's bring it back here. Let's try and get 6 in it. We'll go divisible by 3 blue, divisible by 3 blue. Alright, now this one now has 5 pictures in it, and we'll just do 6 for fun. We already used 5, so let's use 7. Load the embedded picture, so now that is the one that was just here. Let's do green. Alright, so this picture right here now contains 6 embedded pictures in it. Alright, so let's just go ahead and start over. We can either use this clear button, and we can use this clear button, or we can just start over. Alright, so let's go ahead and start over, and let's load back our dog picture. So there's our dog image. And these 3, unfortunately, they take about 15 seconds each button, so I'm not going to do those, but you can try those out. I'm going to go ahead and go right down here. So now I want to load a new picture. This one I can save. So I'm going to choose the dog image, and let's just say randomly I'm going to choose this one. I'm going to choose this one. Oh, I forgot to choose a hidden image that time. So that, visible by red. Oh, there it is. So now what I'm going to do is I'm going to save it. It's automatically going to save as embedded image. So I'm going to start over. I'm going to load that embedded image in there. So someone I can send this to with a similar program. Boom, and now they can see the hidden image. Alright, so this is basically how everything works in our GUI. So I'm going to close out of this. So basically our project has 24 total functions, and our GUI just calls to those functions. So for our first function, for when we did most of our embedding, this is the basic handout, how we use 2 inputs, and then it gave us 1 output that we used to display, and then this was our recovery.
This is the odd even red embedding. What this does is it looks at all the values in the hidden image, and wherever the value is a black pixel, it checks in the corresponding pixel to see if it's odd or even. If it's even, it changes that value to odd by subtracting 3. For the white pixels, it does the same but subtracts 3 to make sure the values are even. This is the recovery for the odd even embedding function. What this does is checks through all the values of the new embedded dog image and checks where the values are odd or even. At the odd values, a black pixel is assigned to a recovered image and all the other values are white. This recovered image is expanded and made into our new recovered image. This is the divisible by 3 embedding method. What this does is checks through all the values of the hidden image, and wherever the value is a black pixel, it changes the corresponding value in the dog image to a value that is divisible by 3. Wherever the value is in the hidden image is white, it changes the corresponding value in the dog image to a non-divisible by 3 value. This is the recovery method for the divisible by 3 method. What this does is checks through the new dog image to see where the values are that are divisible by 3. Wherever the values are divisible by 3, there is a black pixel assigned to that position in a recovered image matrix. Wherever the values are not divisible by 3, a 0 or a white pixel is assigned into the recovered image. The recovered image is the new hidden image. This is the +1 embedding method. What this does is takes a layer of the dog image and adds the hidden image to that layer, and then reinserts this layer back into the entire dog image. This is the recovery method for the +1 method. What this does is takes the image before there was any embedding and takes the image after there was embedding and subtracts the before from the after. The result is the image that we embedded into the other image, which is the hidden image. This is the set 0 and 1 embedding method. What this does is checks wherever the black pixels exist on the hidden image, and at that corresponding point it sets the last digit of the corresponding dog image pixel to 1, and wherever there are white pixels sets the last digit to 0. This is done by converting the value to a string, changing the value, and then putting it back into number format and then back into the matrix. The recovery for this is straightforward. What happens is it checks through all the corresponding dog image values and sees wherever the end digit is 1 and assigns the black pixel to a new recovered image. And wherever the values are not 1 or 0, it assigns the value of white pixel to the recovered image. This recovered image is our recovered hidden image. All these embedding techniques are not only for the red layer, but also for the green and blue. Thus, with 4 techniques and 3 layers, a total of 12 images can be embedded.
The flatten function in our code serves to take a grayscale image and turn it into black and white. It does this by separating values that are lower than 127 and making them 1, while simultaneously grouping values that are larger than 127 but smaller than 225 and making them 0. The expand function looks at the flattened image values and repeats them through the 3 layers.